Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called minimum window substring. It is a hard question, but after my explanation, it won't be so hard, hopefully. So we were given two strings s and t of length m and n, respectively. Return the minimum window substring of s such that every character in t, including its duplicates, is included in the window. If there's no such substring, return the empty string. The test cases will be generated such that the answer is unique. Okay, so the description of this problem is quite short, so let's find out what it means. Basically, we're given two inputs, two strings. One is s, the other one is t. And we're going to form the full string of t within s and return the minimum of its substring that contains t. Okay, so let's take a look. We have Adobe here, code, bank, something like this. The shortest substring that contains ABC would be this one with length 6. Okay, this is a possible answer. And anything else? Oh, we have another one here. This length is 4 and it contains ABC in whole. So this would be our answer. So the output would be this. Okay, and we have another example here, which is a full match. So we can just return A. And if we have something like this, the t is longer than s. Therefore, we can't find any t within s, so we can return an empty string. Okay, so how can we solve this problem? So first things first, when we see a substring and something like this, we naturally think of sliding window. Okay, so how can we slide? We can initialize 2 pointers here, and when we go right, we put it into our current window, and we will see if it is the same with t. Okay, we'll compare these, and once we've found it, we will shrink from left to see if we can find a shorter answer for the minimum window substring. Okay, so in that case, if it's not valid like this, we will continue searching to the right, okay, until we find another match. Then we shrink from left. Here's another match, but we'll shrink further, and it's not a match anymore. So we will go ahead until we find a match. Then we shrink from left. Everything looks good. So right here, it's valid, and we will record the shortest answer to this. Okay, so afterwards we will return the substring with the minimum length. Okay, but to record the minimum length, we have to use some other stuff. Okay, let's break it down. So first we will need to check the corner cases. Okay, that would involve like if we have something like s is null, or maybe t is null, or maybe their length is 0. Okay, so some corner cases like that. Okay, after that we will record the t frequency. Okay, basically the t patterns. So we can save that in the hash map, like character integer. So we know how t is formed. Okay, and other than that, we need to have a required size of the map. That said, if we have this example, we should have a hash map of size 3 for easier comparison, so that we don't have to compare one hash map with another hash map, which takes a long time. Okay, we can just record its size. Okay, so after that, we can initialize our sliding window. Okay, and what do we need for the sliding window? We need a cur window hash map, okay, which is also character integer that's going to match with the T frequency map. Okay, and we need to also record formed characters so far, like formed. Okay, once the formed is equal to the size of the map, of the T frequency map, we know we found an answer, but we have to record this answer in some way. Okay, so I can have a array which records the length of the current window, the right boundary, the index of the right boundary, the index of the left boundary. Okay, I'll just do something like this. Okay, so once we have this, we can have a record of the minimum length, its left boundary, its right boundary, and we can return it at the end. Okay, yeah, so I think that should be the answer. And when we're doing the sliding window, of course, we will use a right pointer to loop through the whole string s, and once s.length. So once we find a match, update the result array, okay, and then shrink from left. Okay, so that's basically how this could be done. Okay, now let's code it out. So first, if s.length equals to 0 or t.length equals to 0, we'll return an empty string. Okay, and now we can initialize the T frequency map, so which is going to be a character integer T map will equal to new hash map, and I will put all the characters in T to this map. Okay, so tmap.put c tmap get or default c0 plus 1. Okay, so now I have all the frequency of the characters in T, and then I will initialize a required size. Okay, so I will just record it equals to tmap.size. Okay, so now we know everything from T. Okay, now let's continue with S. So for S, I will use a sliding window. So L equals to 0, or right equals to 0, starting from the left. And I will have a formed, means how many characters have we formed so far. Okay, so if we have like multiple characters duplicates here, we can have something to record it. Okay, yeah, also we will need another map to record the current window. Okay, and I will initialize a result which is 3. Okay, but yeah, I can do another function here. So I can just use -1 0 0. This means the minimum length, left boundary, right boundary, okay? Something like this. And yeah, I think we're all set. Next, we can initialize the sliding window. R is less than s dot length. What should we do? So we first need to know what character are we processing, and we're going to put it into our current map. Cur window.get or default. Yeah, so now I have the frequency of this. Okay, so now let's take an example here. So I have Adobe C. Okay, so now I have Adobe C. When do we stop? Like, when do we do some condition checks? So it's when we have, how do we know that something is formed? Like I said, if we have like some duplicates like AABC, in that case, if the frequency of one character in tmap matches the frequency of the current window of this character, we know we find a form, right? So if tmap, yes, tmap contains this character, and the current window.get this character's integer value equals to tmap.getC.integer value, we know we have formed something, okay? And if we have formed everything in this for t in S, am I making it clear? So if we have found ABC here, what should we do? Should we go right? No, we should shrink from the left, okay? We should first record this window and shrink from left to see if we can find a shorter window, okay? So if formed equals to required, and it should be valid, okay? So it should be L is less than or equal to R. In that case, oh, sorry, we have to use while loop because we're going to constantly shrink from the left, okay? So character ch equals to s dot character at L. If our result 0 is equal to -1, means it hasn't been updated. So the first time it's been updated, or the current window size is less than the previous recorded window size. At this time, we need to update the result, okay? So result 0 will be R minus L plus 1. And result 1 will be L. Result 2 will be R, okay? So now we recorded the current window and the left and right boundaries. And we can shrink from left, okay? So cur window.put cur ch cur window.get ch minus 1. And if tmap contains this key and the current window doesn't have enough character to match the tmap, okay? So current window.get ch dot integer value is less than tmap.get ch dot integer value, we know we are we're no longer formed, okay? So we have to go next. And after that, we move our left pointer, okay? So that's how we shrink from left. And next, we're going to increase our right boundaries for the next search, okay? So I think that's basically how we can find it. Now let's turn to how we can return, okay? Basically, we can return a substring from the left boundary to the right boundary here, okay? But there's another possibility, which is the minimum length hasn't been updated, okay? So we have to check result 0 is equal to -1, okay? If it is -1, that means we didn't find anything, okay? Otherwise, we will call substring from result 1 to result 2 plus 1 for the whole covered window, okay? Let's see. Okay. Contains key. Yeah, I think it passes all the test cases. Now let's analyze the complexity here, okay? So for time complexity, we're looping through the T1s, and we're looping through the S1s, so it's going to be, is there any other thing left? No, sliding window, so it's going to be S and T in the worst case. For space, I think it's going to be this hash map, T, this hash map, probably S in the worst case. And we have this one, but this is constant. So I think it should also be S plus T. Okay, let's submit it. Let's see. Yeah, it works perfectly. Thank you so much for watching. This is a hard question, and it's natural to have no clue at first. But I think hopefully my video helps you in solving this kind of problem. It's not like that hard, right? And if you like the video, please like and subscribe to my channel. Thank you so much for watching. I will see you in our next video.